In this section, we'll be reviewing how transformations affect a function, in particular exponential functions. Before we do this, let's go ahead and review the behavior of the exponential graph. There's two general cases. And the first case that we'll be looking at will have our b value is greater than 1. If b is larger than 1, then our exponential is increasing. And it has a y-intercept at the point 0, 1. And another common point that's going to be useful will be the point 1b. If our b value is between 0 and 1, then our exponential function is decreasing. Again, the y-intercept is given by 0, 1, and the common point here again is given by the point 1b. Some common characteristics about both of these particular graphs is that the domain is given between negative infinity and infinity. The range is from 0 to infinity, but not including 0. They both have a horizontal asymptote at y is equal to 0, and both of these functions are 1-to-1 on their entire domain. To vertically shift our graph, we need to change all the y values by some constant unit. So if we wanted to shift this graph up by, let's say, k units, we would need to add a k to our y values. And to do this, we're going to change our equation from y is equal to bx to y is equal to bx plus k. When k is greater than 0, then our graph shifts up by k units, and when k is less than 0, our graph shifts down by k units. Before we move on, let me make a note that if we shift our graph up or down, we're going to move our horizontal asymptote in the same direction. So the horizontal asymptote corresponding to our graph y is equal to bx plus k is given by y is equal to k. Now to shift a graph left or right, that means that we're going to be altering the x values so that they're going to different y values. And the way we do that is we replace our equation y is equal to bx with y is equal to b raised to the x minus k. And if we want to shift our graph, let's say k units to the right, then the number k is going to be greater than 0. So our graph would look something like this. And if we want to shift our graph k units to the left, then k will be less than 0. A reflection about the x-axis takes all the positive y values and makes them negative, and all the negative y values and makes them positive. And the way to achieve this using an equation is that we multiply our original equation by a negative 1. And the resulting graph will look as follows. Now, a reflection across the y-axis is a little more interesting when it comes to exponential functions. And this time, let me go ahead and reiterate that our b value is greater than 1 for this particular picture. And again, what we're doing is we're making all the positive x values go to the negative y values, and the negative x values are going to be associated to the positive y values of the graph. And the way we do that is we replace our equation with y is equal to b raised to the negative x. So we're replacing our x with a negative x. And what this does is it flips our graph across the y-axis, but this green graph is now the graph of an exponential whose base is less than 1. And we can see this by rewriting our equation here. This is going to be equal to a 1 divided by b raised to the x. And 1 divided by b is clearly less than 1, but greater than 0. A vertical compression or stretch occurs when we multiply our original function y by some constant. The resulting graph allows us to have y values that are going to be a multiple of our original y values. So for example, if this point was again the point 0, 1, and we wanted to vertically stretch our graph by k units, then our new graph, our y-intercept would be 0k. And so this is, again, done by multiplying our original equation by some constant k, where we have that the absolute value of k is greater than 0. When k is greater than 1, this is called a stretch. And when k is between 0 and 1, this is called a compression.